This is number 4 of the 2.1a lesson, which is essentially the second question. We're going to solve 10 equals negative x plus 3x plus 4. And we're going to start with the algebra tile and then also our explanation. And then after that, we will do the algebraic solving. One of the things that we can do is, and that I would suggest doing, is if we have an equation that it is heavier on the right, that we flip it when we actually do it here. So that means that I'm actually going to draw this first on the left side. So I have a negative x tile, and I always can do this. And I can do it at the beginning. I could do it in the middle of the problem if I want to. And then I have 3 unshaded x tiles and 4 unit tiles, which are equal to 10. 1, 2, 3, 4. There we go. All right, let's double check before we get too far into the problem. We flipped it. We have everything accounted for. And step 1 is any cleanup, which is going to be cancel 0 pairs, because I think I see 0 pairs. Cancel 0 pairs that are on the same side of the equal sign or the boundary line. And so I see that there are a set here. They have to be on the same side, so they can't be across this line. We don't want to cross over this stream. All right, so now we're going to carry down whatever's left over. And then as we think about what to do next, we should start to realize, by the way, feel free to pause the video if you're not ready. We should start to realize we're stuck. There's nothing to do. But we know what our end goal is. Our end goal is to get to this. So the decisions that we're about to make are all to get to what is a rod equal to. So we need to get rid of these tiles because I have a feeling that this step is going to look like this. We need to get these 2 x tiles alone, which means we need to get rid of these 4 unit tiles. And the things that cancel with these are these unit tiles. But I can't just have these tiles show up without justifying why I can do that. And in order to justify it, I need to also do it on the other side. So that's allowed. As long as I do it to both sides of the equation, that's fair. So step 2 is add 4 negative unit tiles to both sides of my equal sign or equation. Step 3, cancel 0 pairs, because we did this so that we could cancel or kill off tiles. These cancel. Those have to cancel. That's why we picked this. And then sometimes these tiles, some of them will cancel. I don't think on the first one that they actually canceled. All right, so we're left with these 2 rods, and we're left with 2, 4, 6. And now we're in, this is step 4, and this is our make groups. So we're going to make some number of groups, and it's always based on the number of x tiles. So we're going to make 2 equal groups. On both sides of the equal sign. So it's going to look like this. 2 equal groups, meaning, well, there's only 2 here, so each group gets 1. And then this side, 2 equal groups. And by the way, if you can't break these into equal groups, if you have an odd number here, then you know you have an error. But 6, I can divide it into 2 groups of 3. So that's also an indication that I did this correct. And so this means my answer for one group, 1x, is one of these groups, which is 3 unit tiles. So my answer is x equals 3. we're going to go to the top and we are going to, feel free to pause though, we're now going to solve this algebraically. And I'm going to do the same thing. When I solve this algebraically, I'm going to flip it, but I want to make sure I do this carefully. Otherwise, it's going to be annoying if my mistake is in that first step. And I'm going to draw in my boundary line, sort of like I had here, my equal sign boundary line. And I'll carry it down. Here it goes. All right. And we'll go back up to the top. All right. And let's think about what steps did we do. Step one was we cancel zero pairs or combine like terms. And if you can't add these, you can always look at your tiles because we already added these actually. So all of the answers to these steps are over here. We're doing the same thing. All right, so then we had 2x plus 4 equals 10, and we added -4. Notice how I'm lining it up under this and under the 10. It's 1 for each side. So this 2x doesn't get 1 because it's on the same side as the 4, and we apply it to the 4 because those are zero pairs. And then these, we can even just count them up here, is 6. Feel free to pause the video. Notice how I line this up. That's very important. Plus -4, plus -4 lined up. And then we had 2x equals 6. And we made equal groups, which is another way of saying divide. And we divided by 2. And we got x equals 3. All right, the last thing we're going to do is we're going to do our verify or our check. Ooh, and they even wrote out our equation here. That's kind of nice. And everywhere where there's an x, I'm going to put a blank because I'm going to plug in my answer. So there were the two spots. We called this evaluate in module 1. All right, so the 3 is going to go here, and the 3 is going to go here. The 10 just stays there, and all we're going to do is just PEMDAS. So this became actually -3 because it had an extra negative, plus 3 times 3 is 9, plus 4 is 10 equals -3 plus 4, -3 plus 9 is 6. The 4 comes down, and we have 10 equals 10. So that checks out. That's what we want to see, that we get the same numbers, but notice these numbers are not the answer. The answer is still 3. Unlike the first problem, I think, where it wasn't the case. So 10 equals 10, answer is still 3, because we got 3 all across this table.